Face ID is probably one of the best things invented. All you have to do is look at your phone and it instantly unlocks for you. So how does your phone know that it's you and not someone else? Here's how. Neural networks are made up of layers of neurons or computational units that take in data, trying to recognize the patterns within them and predict an output. A convolutional neural network, or CNN, is generally used for processing images. Like all neural networks, the CNN has an input layer, which receives information from each pixel of the image, and an output layer indicating the network's response. However, CNNs have additional layers called convolutional layers that contain kernels. Oh no, not popcorn kernels. I mean like small matrices of numbers that look for different patterns in the image. We start off by applying the kernel in the top left of our grid of pixel values. We find the dot products by multiplying each pixel value by its corresponding value in the kernel and summing up these products. The sum is stored in a grid called the feature map. We then slide the filter over and repeat the process. After completing each row, we slide the kernel down and repeat until the entire image is processed. This process is a mathematical operation called a convolution. The feature map actually tells us how much the image feature was present in the corresponding sections of the image. Higher values indicate a stronger presence, while lower values indicate a weaker presence. In a CNN, there are multiple kernels and feature maps for detecting different features. Early convolutional layers might learn low-level features like edges and textures, while deeper layers learn high-level features like shapes and object parts. Wait, how do we know what values to put in the kernels? Initially, we make them random, but determining the right values requires training. This involves optimization techniques like gradient descent, where we find the derivative of the loss with respect to each of the filters. The loss is just the difference between our prediction and the actual output. Basically, we use calculus to tell us how sensitive the output is to each value in the filter and how to adjust these values to minimize the loss. This whole complex process comes down to some math. And this is how CNNs look for features to help make its predictions. So when your phone recognizes your face, it's largely thanks to this intricate process of pattern detection.